This device reads your brain. No crazy wires required, no giant scanners, just light and a headset. Meet fNIRS, the world's most portable, non-invasive brain scanner. Hi there, I'm advanced biomedical engineer and I break down medical technology in a way that anyone can understand. In this video, we'll take a look at what fNIRS is, look at how it works, we'll look at some use cases of fNIRS, and then I'll give you some pros and cons of this technology. Let's get straight into the video. What is fNIRS? fNIRS stands for Functional Near-Infrared Spectroscopy. It is a brain imaging technique that uses safe infrared light to measure blood flow, specifically how much oxygenated or deoxygenated blood an active region in your brain contains. So when a part of your brain becomes active, like when you're solving a really difficult math problem and you're stressed, you are thinking really hard, that part of your brain that is processing the math information requires a lot of oxygen. The neurons over there need more oxygen to function. And fNIRS can detect that change in oxygen levels from outside of your skull using light and some sensors. But how exactly does this work? Here's how. So the fNIRS device shines near-infrared light into your scalp using sources and detectors placed on a wearable scalp or headband. Some of the light then travels through your skull and interacts with the blood in your cortex, specifically in the top few centimeters of your brain. Based on how much light is absorbed or reflected back, the system calculates how much oxygenated or deoxygenated blood is present, and this is a direct indicator of brain activity. So this device is very similar to the fMRI technology, which uses very strong magnets to grab brain activity. In fact, they are both measuring the same signal, which is a bold response, but in two different ways. In this video right here, I covered fMRI and we looked at how researchers basically reconstructed movies from the brain activity of participants that were made to watch a specific movie. This is a really crazy technology. Just watch the video for yourself and subscribe. Let us take a look at some use cases. First on my list is child brain development. fNIRS is a game changer in pediatric neuroscience. Unlike fMRI, which requires a patient to remain very still in the magnet, fNIRS can be used while babies are playing or listening to voices due to how portable the device is designed. Which means researchers can now study how language develops, how babies respond to emotions, or even study how autism or ADHD can be detected early. Second on my list is stroke and rehab. In hospitals, fNIRS is used to track how the brain recovers after a stroke. Patients wear a cap during physical therapy and doctors can see in real time which part of the brain is regaining function or compensating for damaged areas. It's just like having a live window into a healing brain, allowing us to track and monitor most of the processes. I find this really interesting. And the third on my list, which is close to my heart, which I find very fascinating, is brain-computer interfaces and mind control devices. fNIRS is being used in cutting-edge brain-computer interfaces research where people are learning to control computers or robotic arms just by imagining movements. While it is slower than EEGs when it comes to BCIs, it is much more portable and a lot more user-friendly. So that's it for real-time brain monitoring in natural environments. fNIRS is one of the most exciting neuroimaging techniques there is today. It helps us to move from lab-only neuroscience to something far more human. We love freedom, and text like this gives us just that. If you found this video interesting, subscribe to support and check out this video on fMRI. You would absolutely love it. See you in the next one.